Yeah, so hello everyone, this is Varish here, and welcome to Acids, Bases, and Salts Day 2. So, in our previous video, we started our chapter 4 Acid, Bases, and Salts. So, we have dealt with some other chapters like ionic charge, nutrition in plants, matter, and stuff. So, this is our fourth chapter, and in the first video, we classified objects like acids, bases, and salts. Okay, and then now we dealt with acids. Okay, we dealt with acids. Now in this video we are going to deal with bases, and in our next video we are going to deal with salts. And there are a lot of more. There are a lot many concepts to cover in this chapter. So we'll go step by step. Okay. So yeah. Let's have a recap on acids. So acids have a pH or power of hydrogen which is less than 7. If the pH is 1, it's strong, and if it's close to 7, it's weak. It tastes sour. It neutralizes bases. It has a corrosive reaction, and it mainly produces hydrogen gas if it reacts with metals. It's a good conductor of electricity. It turns blue litmus red, and it produces H plus ions. Now we have seen with the Arrhenius acid, Svante Arrhenius, who is a scientist, he gave a theory on acid saying that he checked it out. He was like, he added uh, acids, drops of acid to water. Yeah, you should add acid to water, not water to acid. It may cause a false, a big reaction. If that's especially with the strong acids. Okay, so Arrhenius guy, that Svante Arrhenius, he gave a theory that if acid is added to water, it produces hydrogen ions. And the Bronsted-Lowry theory is that when an acid is there in a reaction, it donates hydrogen ions. Now there are weak acids which have less acidic content, high water pH close to 7. Okay, and they do not ionize completely. Example: acetic acid, boric acid, nitrous, phosphoric, sulfurous, etc. Strong acids have high acidic content, less water, they are concentrated, pH close to 1. They ionize completely. Example: sulfuric, hydrochloric, nitric, hydroidic, etc. Now the common acids can be HCl first, which is stomach acid, H2SO4, which is sulfuric acid or for the car batteries, then HNO3 for explosives, HC2, H3O2 acetic acid, vinegar, H2CO3 carbonic acid sodas, H3PO4 phosphoric acid flavoring. So these are just names of few acids which we use in our daily life for our daily purposes. We use it, but we generally don't know what are these acids. So we have come to know now. It's good. Yeah. So this was a recap, and now we have seen the acidic one from, like this, and this is the alkaline or the basic scale which we are going to deal with, and the middle one is neutral. Okay. Now bases. Now let's come to bases. Now acids are a different type of substances. Now bases are some different type of substances. Now it's really interesting to deal with them. Okay. Now the first thing is pH, because we have classified everything based on pH. Acids from 0 to 7, and neutral substances exactly 7, and bases from 7 to 14. So it depends on the hydrogen molecules or the content of hydrogen present in a particular substance. So the power of hydrogen over here is 7 to 14. Okay, and next, its pH is, if the pH is close to 7, it's weak, and if it's close to 14, it's strong. So that was opposite. It was the opposite case for acids, right? Yeah, if it was close to 7, it was really strong. If it was close to 7, it's a weak acid, and if it was close to 0, it was strong acid. So basically, as the number decreased, the concentration increased, whereas over here the number is increasing, the concentration is also increasing. Okay, so if it's 7, it's weak. If it's 14, it's strong. Okay, next is it tastes bitter. Acids taste sour, bases taste bitter. Bases also feel slippery. Yeah, example of a base is a soap. When you have a soap in your hand, it's very slippery. So it's one property of a base. it neutralizes acids. Like if there is an acid, bases can cancel out the acids, and thus there is, so it is neutralizing. How acids neutralize bases, bases neutralize acids. For example, if we take the acids as the hot stuff and bases as the cool stuff, these bases can neutralize acids, so cold neutralizing the hot, whereas acids can neutralize bases, so the hot neutralizing the cold. So we can relate it like that. It produces OH minus ions or hydroxide ions. Hydroxide, we have dealt with ions, it's hydroxide ions, okay? And it dissolves fats and oils. So these are the features of bases. Now bases can be of two types, weak bases and strong bases. We have dealt with weak acids and strong acids, so it's similar, but it's not acids, it's bases, okay? Now weak bases have less basic content, they have high water, so less concentration or less basic content, high water, and pH close to 7, so they are weak bases, okay, so less concentration and stuff. Examples can be ammonia, potassium carbonate, sodium carbonate, etc. Strong bases. Now strong bases have a lot of basic content, less water, so you need to be really careful in handling these stuff, and pH is close to 14. Okay, so examples can be sodium hydroxide. Now NaOH, it's a really strong base, like how sulfuric acid is the well-known acid in the category of acids. Over here, sodium hydroxide is the strongest base which we see. Okay. And other examples can be sodium phosphate, barium hydroxide, calcium hydroxide. If you see over here, most of them are hydroxides, but over here one is phosphate. It's all due to the reactions and stuff. Okay, but as we saw it produces hydroxide ions, so we can relate to it like that. Okay. Now the common bases which are present, NaOH, as I told you, sodium hydroxide, it's used in soaps and drain cleaners. MgOH2, magnesium hydroxide, and antacids. Antacids are the stuff you use. It's all, so there is something called milk of magnesia. Okay, that's also something like this. And then AlOH3, aluminium hydroxide. It's also used for antacids and deodorants. NH4OH, ammonium hydroxide. It's used to create ammonia. Ammonium hydroxide, in that ammonia is extracted basically. Okay, so these are some common bases, and they are mainly used like for antacid, soaps, drain cleaners, toilet cleaners, and stuff. Okay. Now here comes again Svante Arrhenius. Okay, we have seen Svante Arrhenius acid. It says that an acid produces hydrogen ions in water. So Arrhenius base, it produces hydroxide ions. Okay, in 1800, Svante Arrhenius produced a theory on bases. It's called the Arrhenius base. Basically, it is nothing but it produces hydroxide ions in water. Now Bronsted Lowry acid, it donates a hydrogen ion, but in Bronsted Lowry base, it accepts a hydrogen ion. So in an acid, it used to donate; in a base, it is accepting. So that's the difference we can see. Okay, so we dealt with these bases in this video. So we are done with acids and bases. So in the next video, I will give a short recap on the bases, and now we are going to deal with salts and neutralization reactions, and then we have a lot to deal with, like why are we using these stuff, and then the indicators. How do you see whether substance is an acid or a basis? Suppose you are given a transparent liquid, and it's a really strong liquid. Okay, and it's a really strong one. It might be an acid, base, or even a salt. So how can you identify it? You can't taste it. You can't taste sulfuric acid or sodium hydroxide or stuff. So there are special stuffs called indicator used for indicating. And we'll continue the chapter in the next video. Hope you learned something about acids, bases, and salts in this video. I'll continue the chapter. Until then, bye bye.